Let's talk about another problem in vectors. The problem goes like this. I cap and j cap are unit vectors along x and y axis respectively. What is the magnitude and direction of I plus j and I minus j? So we have to find the sum of I and j and difference of I and j, and we have to comment on the magnitude and direction of it. What are the components of vector A, which is 2i plus 3j, along the directions of I plus j and I minus j? So once you have identified the directions from the first part, we have to resolve this vector A along those directions. Let's start solving this question starting with the first part. So in the first part here, I have taken the sum of I and j. So I have drawn the I cap along the x-axis, j cap along the y-axis, and I'm adding them using parallelogram law, obtaining this blue resultant over here. If you have any doubts in how to add two vectors using parallelogram law, you can go back and watch the video of how to add two vectors using parallelogram law. Now in this case, if I directly apply the formula, which is square root of a square plus b square plus 2ab cos theta for the magnitude of the resultant, I will obtain this expression as you can see, and the result of this comes out to be square root of 2. So the magnitude of this vector is square root of 2. Now to identify the direction, I'll apply the formula for tan alpha, which simply comes out to be tan alpha is equal to b sin theta upon a plus b cos theta. Angle theta is the original angle between the vectors. So if I plug in the values, the answer comes out to be tan alpha equal to 1 and alpha is equal to pi by 4. So this resultant makes an angle pi by 4 with the I cap vector, which means over here the direction comes out to be this one. Now similarly, if I carry out I cap minus j cap, for that if I have to carry out the subtraction, I have to interpret minus j cap separately, which is simply the reverse of the vector j cap without affecting its magnitude. So over here you can see this is my j cap. This is exact reverse of j cap without affecting the magnitude of 1. So if I add I and minus j now, which is equivalent to subtracting j from I, the resultant I obtain is over here. Now once again, if I apply the formula for magnitude, the result comes out to be square root of 2. So in both the cases, the resultant have a magnitude of square root of 2. However, in this case, if I apply the formula for tan alpha, I'll get the answer as minus 1. You can plug in the values yourself and check the answer. And in that situation, my angle alpha comes out to be minus pi by 4. Over here, alpha was plus pi by 4. So I can clearly say that these two vectors, if I put them together, they will be perpendicular to each other because the angle between them will be pi by 2. Now, once you have understood this completely, we can go forward and calculate the components of vector 2i plus 3j along these two new directions. So over here, we have 2i plus 3j, which has to be resolved along I plus j and I minus j. So first of all, I take the older coordinate axis and I draw 2i plus 3j as you can see here. Now the magnitude of this vector is clearly square root of 13 and the angle it makes with the x-axis is tan inverse of 1.5. All these values you can very easily calculate. Now I have to resolve them along these four vectors. As you can see, this is I plus j and this is I minus j. As you already saw, the angle between them is pi by 2. Now if I extend them backwards, I can have my entire coordinate axis ready and I will extend them even further, creating into a new coordinate axis. So over here you can see I have created a new coordinate axis with new x-axis in the direction of I plus j, the new y-axis in the direction of minus I minus j, right, and their reverses. Now my job is to break this vector along this axis and this axis. Now according to the law of resolution, all I need to know is the angle between this vector and this new x-axis or any other axis, so that I can start the process of resolution. If you have any doubts in the process of resolution, you can go back and watch the video of resolution of vectors. So carrying ahead, we have to calculate the angle this A vector makes with the new x-axis. Now for that, I already know the angle that this new x-axis itself makes with the original x-axis, which is nothing but pi by 4. We saw that in the last section. So to calculate this angle, I have to simply subtract this from this entire angle. So the result of this angle comes out to be tan inverse of 1.5 minus pi by 4. Now to break this vector along these two axes, we have to use the concept of resolution. Now for that, essentially we have to drop two perpendiculars from the arrowhead onto each axis. So as you can see, this is the construction, and the two resultant vectors will simply be the vectors starting from the origin ending at the points of intersection. So over here, this small vector over here and this large vector are my resolved components along this new and new y-axis. If you have any doubts in the concept of resolution, please go back and watch the video on resolution. So carrying ahead, the value of the magnitude of this vector along the x-axis will be nothing but root 13 cos of tan inverse 1.5 minus pi by 4, which is simply magnitude into cos of the angle with the x-axis. The result of this comes out to be 3.53, and similarly the y component, which is along the y-axis, will come out to be root 13 sine of the angle. So sine of tan inverse 1.5 minus pi by 4, the result comes out to be 0.707. Now I can see that this x component is along the direction of I plus j. So I can say that the component of this vector along I plus j is 3.53. However, this y component is actually along minus of I minus j, and I am supposed to answer along I minus j. So I can say the component of vector along I minus j is actually minus 0.707. So the answer for this question I get is the component along I plus j is 3.53 and component along I minus j is minus 0.707. I hope this is very clear to you. Thank you.